Hey everybody, Mr. Bowman here. This video is on 3.13 probability concepts. In particular, we're focusing on all the merit questions from the 2021 exam. If you're looking for more merit questions from previous exams to focus on, check out the link in the comments or the description, and it'll be a good link to get your studies going. So let's get straight into question 8. And this one here was a bit of a wordy nightmare question, so there's no other way to go about it apart from breaking down the wording with you all. So a music festival is selling two types of tickets. We've got early bird tickets and general admission. The fact they're talking about two of something could mean two things. It could be a split in a probability tree, or it could be, a branch, early bird, not early bird, or it could be the side of a table or something like that. So that's kind of where I'm initially leaning towards. It could be one of those. We're not quite sure what yet though. For each type of ticket, there are people who are under 16 who can buy a child's ticket. Otherwise, they're an adult ticket. So again, that doesn't learn anything new. That could be the next split in a tree or the next part of a table. So we've just got to figure out, really the differentiating outcome is, are we going to have some kind of conditional probability? If it's conditional, it's definitely going to be a tree. So early bird tickets need to be purchased for a particular date. And then the cheaper tickets are the general admission ones. For both early bird and general admission tickets, the child tickets are cheaper than adult ones, so that makes sense. So for the 2021 festival, 1/5 of the tickets sold were early bird type. Great. And this is what I'm looking forward to seeing. This is the gold nugget for these early bird tickets. So that 100% confirms a tree. We had our early bird tickets, and then 100% confirms, well, something else happens afterwards. So big fan of that. So let's do our first split actually, because we know what it's going to be. So the first split is going to be, it's going to be an early bird ticket or it's going to be a general admission ticket. And earlier before it said 1/5 of the tickets sold were the early birds. So that's going to be 0.2 there, which means the other 0.8 are going to be the general admission types. So for these early bird ones, 3/4 were adults. So that's going to be the adult and the child split. So that there is going to be 0.75. Down the bottom there, that's going to be the other 0.25. For general admission tickets, 2/3 of them that were sold were adults. So that's my next split here, my general admission split. That's my adults, that's my children. I'll put these as a fractions. That there is 2/3 and that is 1/3. So I put them as a fraction because it's a bit annoying to deal with thirds, as you might know. So was it more likely for an adult to be sold an early bird ticket or a general admission ticket? So this is a conditional question. So really we're looking for one of two things. So it's basically, are we trying to find the probability that they are early bird given they were an adult? And then we're trying to find the probability that they had a general admission ticket given they're an adult. And we're going to compare the two to see which one was more likely. So thinking of my branches, so the branches that relate to adults are going to be this top branch up here and this kind of middle-ish one down here. So to find the total number of adults or the total proportion that are adults, we need to find these two outcomes and we need to add them together. So when I find this top outcome here, we know we multiply the two branches together. So that there is going to be 0.2 times by 0.75, and when I multiply those together, I get 0.15. The next thing to deal with, well, I've got 80% there and 2/3 there, so I'm going to multiply those together now. So I've got 0.8 times by 2/3, and when I get that on my calculator, I got 0.5333. And adding those together, that gets me to 0.6833. So this 0.6833 number is really important because that's going to be the denominator of the fractions that I'm going to make. So let's start by doing my calculations. I'll start them over here. So the probability that they are an early bird given they're an adult, that's going to be, well, I know the bottom is going to be 0.6833, but of these two numbers, which related to the early bird tickets, and that's actually the one on top there, isn't it? So 0.15, and when I find that, put that into my calculator, I'm getting 0.2195. So now that I've got that, I know the other portion, so 1 minus that number, that has to be the general admission people. So I can then find, well, the probability of a general admission given they're adult, well, that's going to be equal to 1 minus 0.2195, and when I plug that into my calculator, well, I got 0.7805. And we can see by comparing these two numbers, they are way more likely, the adults are way more likely to to go into the festival with the general admission ticket as opposed to the early bird ticket. Let's put that in a bit of a paragraph. So as the probability of general admission given adult is larger than the probability of early bird given adult, we know that it is more likely, forgot how to spell there briefly, more likely for an adult to purchase a general admission ticket, so a GA ticket, than a EB ticket, than an EB ticket. There we go. So that wraps up that short little intro. We're now into question number 9, and straight away, just by looking at the formatting of the question, all the bullet points, hopefully your teacher's told you, that's got to be a three-way table or a three-way Venn diagram question. I exclusively teach three-way tables to my class just because I think it's a really good skill, and every so often a Venn diagram is a bit tricky and may require a bit of algebra, but the three-way table will never require that. So let's start. I'll start by drawing the table. I always do that. So I've got three festivals operating over the summer. You've got I, E, and S. I won't bother saying the names properly. So let's draw our table. So I is the first variable. I'm going to draw that over here. I'm going to draw it a bit bigger than some of the other videos I'm making because I definitely ran out of room for the coding for some of them. So there's I. The next one is E. So could have been E or not E. And then same thing, E and not E. And then finally, the only one I can pronounce properly, serendipity. My pronunciation of things is awful. S and S dash. So that's kind of the three variables I'm dealing with. I'm now just going to connect it all up to make my grid. There's my grid. Cut that in half, cut that in half, cut that for the third variable. And then I can do my totals. That's my total for I. That's my total for I dash. Those there are my S and S dash totals. And down the bottom there, that can be my grand total. So let's get into this. And just a reminder, the best strat for these are listing the outcomes in the questions when you're not sure about them. And obviously the coding method that I'm going to show you through this. Okay, so I suppose the first number I can see up here, 37, that looks like it's the grand total. That's the different acts performing across these three festivals. So let's jot that down there. So that's going to be 37, so give that a tick. The next one is Ideal, I think, offers 17 acts, so that's over here. So that's 17, which means we know this one here to be 20, tick. Escapade offers 14, that's the E. So annoyingly, remember your middle variable, that's the annoying one for three-way tables. So let's code that. Let's just put a little plus sign here, 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 and here. And I know to come back to those because all of those plus signs add to 14. So when I've got three of them, I can then use a bit of math to figure out that fourth one. So give that a tick. I've dealt with that. And serendipity has 29. So I know that's 29 down there, which means that bottom one there must be 8. So 5 of the acts seen at Ideal can also be seen or also perform at Escapade or E. So I and E. But the issue is this sentence here, it's a bit silent on S, so we don't know which one of S that is. So this here is actually going to be two options. It's going to be I, E, and S, or I, E, and S dash. So we don't actually know which of the two combinations it is. So we're going to again have to code it up. So I, E, S, that's going to be that one there, and I, E, S dash, that's going to be that one there. So those two there have to add to that 5. So let's add on a code, circle, circle, and all those circles have to get us to 5. Give that a bit of a tick there. We now got the next one, so similar style, we've got I and S have to be 13. So that could be, don't forget, it could be I, S, and E, or it could be I, S, and E dash. We don't know about what's happening with E for these two, for these 13 people. So we've got I, S, and E, so that's this top one up here, and then we've got I, S, and E dash, that's down there. So those two there, those, we'll call them a triangle for our code, but they have to add to 13, I think it was. So triangle there, triangle there. So those triangles are going to add to 13. So give that a tick. And then finally, 3 can be seen at all festivals. So that's that one there. 3, tick. So there's a bit of a trick coming up to this question, but let's quickly run through the rest of it. Now that I know that one there, that gives me a lot of information because you can see all the codes there. So it's going to link in well. So let's deal with the triangles first. The 2 triangles had to get to 10, so to 13. So that means that one there must be 10. So that's our 13. So that's our triangle code dealt with. We could deal with our circle codes too. Those circles there, they have to come to 5. So we know that one there is going to be 2. So we dealt with that code there. These 4 here have to add to 17. So we've currently got 15 combined to there. So the remaining 2 has to go there. Still don't have the plus signs, which is annoying. And we've got no other way to figure out these ones here as well. And this is where I think a lot of students hit a wall. But there's a bit of context that you needed to make a connection here. So we had 3 different festivals operating. And here we got these 37 performers are performing at these festivals, right? So I guess the question is, this box here is really relevant for us. Not I, not E, not S. So these 37 people, or groups, or whatever they are, we know they're going to be performing at some of the festivals. So that there is actually going to be 0, because they wouldn't be on this list if they weren't performing at any of the festivals. So that's the trick number there. That's 0, which means we can now figure out this number here, which is a 4. We can now deal with all the plus signs. So the pluses have to come to 14. So we had 3 plus 2 is 5, plus 4 is 9. So that remaining one there had to be 5. And then finally, I'll probably do it there. All of that has to come to 20, which means that group there is 11. So that one there was a bit of a trick. And remember, there always is a trick. There's a real cruel one in the 2024 exam. Have a look at that if you're curious. So I guess the question now that we've got, so it is a merit question, so we're going to talk about some probabilities. So which festivals have the greatest probability of seeing the same acts? So basically we're trying to compare, I and E, I and S, and E and S. We're trying to figure out all of the combination of 2 festivals to see what had the greatest overlap in terms of probability. So let's get into that. So I suppose we need to write down our notation. So we're trying to find the probability that someone's performing at I and S, the probability that someone's performing at E and S, and then finally the probability that someone's performing at I and E. So I and S, it's going to be tricky because I and S doesn't consider E, so we need to consider a few different boxes here. So I and S, so I and S, I think are going to be those 2 there, right? So it's going to be 13 out of the 37 people. So there's a bit of an overlap there. So, oh gosh, 13 out of 37. And then finally E and S. So my E and S, so that's E and S there, that's E and S there, that's 8 out of 37. So straight away we know that's going to be lower, isn't it? Because of 8 is less than 13. And then finally we've got I and E. So I and E, that's just going to be these 2 here, isn't it? That's going to be a 3 and the 2 added together to be 5. And then we can see that's the kind of the most likely, isn't it? So based on that, E and S is the highest probability, isn't it? Nope, sorry, I and S. Not sure why I circled E and S. I and S is the highest probability of having the same acts. So we can go ahead and answer the question. So just writing it down here, as the probability of I and S is larger than larger than, I've got my notation, I don't need to write it up fully, right? Let's be a bit lazy. Take the shortcut. Probability of E and S and the probability of I and E. We know that ideal and serendipity have the greatest probability of seeing the same act. Have the greatest probability of seeing the same act. So that wraps up that question. So we're now on to question number 10, and this is the third and final merit question in this exam. There weren't many merit questions here. 3's a bit on the low side, but let's get into it. So we've got some festivals again. So we had a festival theme this exam. We had 1,000, so the first 1,000 festivals buy their tickets online. So 1,000 is probably a total here, or maybe the bottom of a fraction. The data gets summarized by age. So we've got two options. We've got less than 25 or over 25. And then their main motivation. So we got their options, or their main motivation, dancing, socializing, or other. So it could be either thing. It could be a table, a two-way table considering the age and the main motivation, or it could be a conditional probability tree. Let's keep going. So 750 of them were less than 25, and the main motivation of these is to dance. So the main motivation of these refers to the less than 25-year-old. So that's a conditional element, right? So I'm thinking here I'm going to do a probability tree. You could probably do a table with this one too, but let's go with a tree, I think. So the first split is going to be less than 25, and then the second split would be over 25. And then we already talked about the main motivation coming from these splits, so the next split will be about their main motivation. It will be dancing, socializing, or other, and then same thing over here, dancing, socializing, or other. So we just need to get those probabilities now. So we know that less than 25 was 750 out of 1,000, so we just put them in a fraction form. 750 over 1,000, which means over 25 has to be 250 out of 1,000. And we know that of these 750 people here, the main motivation to dance was 510 of them. So that's going to be 510 over 750. The remainder of the young attendees are split evenly between socializing and other. So there's 240 left over, so it'll be 120 split. So that there will be 120 out of 750, and then same thing there, 120 out of 750. And then we're going to repeat the same. Hopefully we've got some information on the older people. There you go. For older people, 160 are mainly interested in socializing. So that there's going to be 160 out of 250. And of the remainder, 60% is interested in dancing. Gosh, okay, so there's 90 extra, so 90 left over, 60% of dancing, so that's 54, isn't it? I've got these in the wrong place, haven't I? So that 160 should be in the socializing group. So that's 160 over 250. 60% of 90 was 54 of 250, and the remaining 36 will have to be down the bottom of 250. Gosh, so we've broken down the tree, broken all the information, we've got into a tree. Let's now get into the question. The festival organizers claim that it's twice as likely for younger participants to be interested in dancing than older participants. So these ones are quite nice. These are conditional questions. So we're trying to find, well, what's the probability they're interested in dancing given they are less than 25? And then we need to compare that with the probability of going dancing given they were over 25. And I don't really mean go dancing, I mean the main motivator is the dancing part of it. So let's compare all those. Gosh, it's going to be a bit annoying to deal with this, I think. Oh, no, it's not. We've got these probabilities in the tree, haven't it? So this branch here, dancing, given they're less than that, that's just going to be this number up here, isn't it? So it's already conditional. We've already got that there. So that's 510 over 750. I briefly thought we're going to have to multiply along the tree a few times, but luckily we don't need to do that because the tree's already got these conditional bits. And then probability of dancing, given they are old, so converting that to the decimal, where was I? I got it written down here, 0.216. So now that I've got those, we can clearly see that this group here is way bigger than the other group here. So to find, they've claimed twice as likely, so we're going to have to do a relative risk just to get the exact number. So they're claiming it's 2. Let's see. I suppose they say at least 2, so it could be 2 or more. So our relative risk here, remember relative risk is always the big probability, 0.68, divided by the small probability, 0.126. And when I do that, I got 3.15, and that there is definitely greater than the 2 that they're claiming. So that matches up with their claim. It's actually it's well beyond their claim, but still their claim is sufficient. So let's talk about what the relative risk of 2.15 actually means, and then let's talk about how it supports the claim. Okay, so do it down there. Hopefully we've got enough room. So a relative risk of 3.15 tells us that those under 25 are 3.15 times more likely to have dancing as their main motivator when compared with those those over 25. So that's the relative risk number. I've run out of room. I've planned the space poorly, but after that we just need a clear statement that we agree with the claim. So as 3.15 is greater than 2, this supports the claim.